Assalamualaikum and good morning. Today I'm going to present to you my progress report titled The Development of Biochar Activated Carbon from Bamboo as an Absorbent using Self-Sustained Carbonization, where you control the carbonization and surface modification for ammonical nitrogen removal. So my name is Sharifah Nazira binti Hamid. My main supervisor is Professor Madia Dr. Jufri Idris, and my co-supervisor is Dr. Technology Siti Katina Abdul Karim. So as an introduction, as we know that the usage of water for agricultural is crucial to meet the global food demand, where your population is going to be increased to 7.8 billion and the population of Malaysia is going to be at 33 million. And these agricultural activities, they produce ammonical nitrogen, where it is due to the usage of fertilizer and through leaching, runoff, precipitation, and it causes eutrophication in the freshwater and marine ecosystem. So here, the conventional methods from Ministry of Health that we do the absorption at the coagulation process here before disinfection. So you can use this bamboo absorbent with the polymer and alum in the flocculation process, where it can remove this ammonical nitrogen. Okay. And here, other studies have been done using coal, coconut shell, wood, sugarcane bagasse, soybean hulls, and nutshell. So in order to prepare this activated carbon, we need two basic steps. So the first one is the pyrolysis using nitrogen. And then here you can control the carbonization through temperature, heating rate, and time for the combustion. Not combustion, carbonization. So here, in order for it to achieve a good quality, they need to have a good absorption ability. So if it have a low absorption ability, you need to undergo another activation process for maximizing the pore diameter and the surface area. So here, the conventional type here is the physical using heat, and chemical using chemicals, physiochemical using heat and chemical, and then last one is the microwave assisted activation using microwave. And the problem with this conventional activated carbon is that they are expensive for this regeneration process from planting and for converting it to the biochar or an activated carbon. So here is my proposed flow for my project, for my PhD. So at first you have to cut the bamboo and put it in the self-sustained carbonization. Then you undergo controlled carbonization with surface modification, with chemical activation, and then you undergo the absorption process for ammonical nitrogen. And status of my research milestone. Okay, here this gives for the problem statement that we need to see the effectiveness of this bamboo in removing this ammonical nitrogen from this agricultural wastewater using jar test. Then you have to study this performance of this bamboo, and then you have to study the time, temperature, the pH, the time, temperature, and initial concentration, so that you would see that how this bamboo can be optimized as efficiently as possible. And here my research objective, and the first one is to evaluate and characterize this raw bamboo and the self-sustained bamboo in terms of ultimate, proximate, and surface morphology, and then to evaluate this activated carbon produced from this controlled carbonization at different temperature and time, followed by this chemical activation using phosphoric acid. But then we will check the characteristics first before undergo other type of absorption. And then the third one is to study the kinetic modeling of this Langmuir for absorption capacity using this ammonium nitrogen, okay, in a jar test. Then we evaluate the performance here to the what do you call the plantation agricultural wastewater to evaluate the pH, COD, BOD, and turbidity before and after the absorption. The scope of study here, first one is we need to study the activated carbon as absorbance and to study the self-sustained carbonization. And then we have to study the control carbonization, and then we have to do the kinetic absorption, and lastly we have to do real application with agricultural wastewater. So in this limitation, we are going to carbonize it at 300 to 500 in a subscale carbonization reactor. Then we undergo the control carbonization for chemical activation. And then lastly, the absorption of this ammonium nitrogen to see the parameters and to produce optimum parameters for the temperature, mass dosage, and initial concentration of this removal of ammonium nitrogen. And then in this literature review, as you know, the absorption is a surface-related process where it works physically through van der Waals forces in the pores or in the chemically bonded for the contaminant and the biochar, or what we call activated carbon, to undergo absorption. And this mechanism have interaction where you have hydrogen bonding, where it undergo pore filling for what do you call that, for absorbing the contaminant. Then here, as you know, bamboo biochar, it have large surface area, high porosity, high functional group, and high cation exchange capacity and stability. So here it have micropores, mesopores, and macropores, where when you study it, it have 4 times absorption rate, mineral content, and have 4 times cavities and 10 times surface area compared to wood charcoal. And here it's larger when you compare it with the carbon nanotube. And in this literature review, we want to check or want to study the slow pyrolysis of self-sustain at 300 to 500 degrees Celsius. And then want to study about the chemically activation of this biochar production, activated carbon. And here we will study the carbonization parameter, proximate analysis, ultimate analysis, surface morphology, which is the bed surface area, pore volume, and the diameter of the pore. Okay, here we want to fill this gap of research in our objective 2. And here is this study where we use phosphoric acid as most of the previous research have done for 1:5 ratio. Okay. Then for ammonium nitrogen kinetic study, there have also been studies that absorb this ammonium nitrogen using bentonite clay, activated carbon, sugarcane bagasse, zeolite, limestone. So here we are going to do using bioactivated carbon of Dendrocalamus asper and Bambusa vulgaris. And here we're going to check the pH, COD, BOD, turbidity, and ammonium nitrogen concentration after the absorption process. Okay, here we can find the novelty where we can reduce the time, energy, and cost of producing a quality activated carbon by using appropriate carbonization technology where it's a self-sustained technology. And here is my research methodology from my first objective to produce self-sustained bamboo biochar, then convert it into activated carbon and undergo absorption, and lastly the real life application. In this research methodology, Here we collect it and cut it, and in order to analyze it, we have to grind it into a fine powder. Okay, for our first objective. And here is the self-sustained brick reactor. And for our second methodology, I'm going to use the chemically activation to produce a high quality activated carbon which have a high proximate ultimate surface morphology, high or the best quality of activated carbon that have a high quality of this characteristic. Then the surface actually it is the chemically chemical modification with chemical activation, okay, where you impregnate with phosphoric acid at 1:5 ratio. Then you have to check for the absorbance for this surface modification. Chemical modification. Okay, and the analysis for the characteristic is going to be proximate ultimate surface morphology functional group for this study. And our third objective is to produce what do you call kinetic Langmuir-Freundlich isotherm modeling from the three parameters that have been suggested, where we varies the temperature, mass dosage, and initial concentration. And then this research methodology, where we use this jar test, where you fix the pH at 7, 120 rpm, 50 milligram of biochar, and 100 milligram of ammonium nitrogen concentration. So it varies the temperature, mass dosage, and initial concentration for this reaction. And here, after the temperature, mass dosage, and initial concentration, the kinetic Langmuir-Freundlich isotherm is done using the graph and Excel, and to produce the CE and the QE for this isotherm model. Okay, and you have to compare the R square, the QE, and the experimental and the actual QE, and the calculated QE from the graph. And here, the last objective is to test it with the wastewater and to check for the pH, the COD, the BOD, the turbidity, and ammonium nitrogen before and after absorption. This is analysis. And here, the research significant here is to provide the technology and to provide optimum carbonization and activation process that have high absorption efficiency, and to provide mathematical kinetic modeling for this temperature, mass dosage, and initial concentration for this ammonium nitrogen absorbance. And lastly, to provide information on the bamboo species that is more suitable to produce a high efficiency biochar in terms of percentage in the removal of the pH, BOD, COD, and turbidity. Okay, in this data collection, this is what I have done. I have done all the raw and the self-sustained. I just have problems for, obtaining the result for my, what do you call that, the activated ones, because some of the results is not that accurate, so I need to redo most of it. So here is the FTIR analysis, where from the raw and the self-sustained, it contains OH stretching, double bonding, and CH stretching, similarly to the structure of this bamboo biochar here. And here, the after the carbonization, it shows some double C bonding and stretching. So it shows some of the surface functional group have been uh, created from the carbonization process. Okay, here also comparison. Here is the same images. So the same images for the raw compared to the self-sustain. Yeah, the self-sustain has produced pores from the structure for absorption, and also it produced mostly macropore from self-sustain, and this carbonization at 5 hours. And this one is from the Bambusa vulgaris raw. So you can see here that the self-sustain have produced some pores, macropore in the structure for absorption. And here is the proximate analysis where it have high fixed carbon, and here also here it have high ash and not that high fixed carbon content. So here's the ultimate analysis. I think we have double of the slides. Okay, and here is the ultimate analysis where you have carbon, hydrogen, oxygen, nitrogen, and sulfur, where the raw Bambusa vulgaris have produced high carbon content here, the upper one. Okay, and this is the BET analysis where you can see that some of the value for the chemically activated using phosphoric acid at 900 degree produce 500 BET surface area. Okay, 535 meter square per gram. Here is where my problem, where the result is not consistent, so I need to redo most of it. And this is the table that I will fill after I finish my activation. This is the last part. After the optimized parameters, I will put inside the water quality efficiency test. So most of it has been done, but most of it have to be redone if the result is not as consistent as the literature and as the other result or samples. So supposedly I'm finishing, but I still have to do the objective 4 here. So this chart will be updated later. And publication, I'm intend to publish this year during this July-September break for the production and characterization of this raw and self-sustained bamboo biochar. And I haven't write my thesis because my result haven't been completed. And planning. Okay, I'm planning to send my samples to FTK and updating the results. And I'm doing the activation now at the campus Samarahan 2, UiTM Samarahan 2, during the semester break. Thank you.